Hey, this is going to be another lesson here for Computer Science 111. Last week we checked out some if statements, a bit more with conditionals this week. Here's a quick overview of what we're going to see, a little bit on comments, and or not. Then we're going to start jumping into loops here. And just kind of a warning here, loops are kind of where a lot of people get lost in the course. So I'm going to try to go into as much depth as possible here in this video. If you feel like you're getting lost, please let me know, when you're working on the assignment, or when you're watching the video or whenever, so that I can try to get you back up to speed, because it's a kind of a new concept here that a lot of people have a difficulty wrapping their brains around. It's not something you really see anywhere else other than in programming, where other things kind of are, setting up variables and data types and conditionals are kind of, they're real world, they're mathy kind of things like that, whereas loops really are not. But before we jump into that, I just want to make it a quick note here on comments. So in our code, a lot of times what's going to happen is we're going to get, a bunch of code going on, X is 5 or Y is 10, something like that. Maybe we're inheriting code from somebody, and we want to just kind of make a note, what this is. So the way you can do that is with the pound symbol. Let me see if I can zoom in here. Make this a little more clear. There we go. All right, so what this pound symbol does is it's called a single line comment, and it allows you to write kind of code to yourself for later on or for another developer. So when I run this code, this does not get interpreted by the interpreter, but rather it just gets ignored. So anything you add in it, this will be ignored. It's really just for developers. And the syntax to do that is just the pound sign, and then whatever you want. After that, you can write more comments, and then it's gonna basically once it finds that, it's just gonna say, well, I don't care about any more of this stuff. So that's a single line comment. If you've got to make a like a bigger comment, you can use multi-line comments, which are with 3 quotations, either single or double, as it says here. They're the same thing. So a lot of times what you'll see is something like this. Something like that. And then maybe even. I don't even know what week this is, 5 or 6 or something like that. So you'll see people use this. It's called it's from JavaDoc basically, and it's this thing that'll parse your code and read your comments and make documentation based on it. So a lot of times if you're looking at code, you'll see something like this in there, and it's just a little tag that helps the documentation things. We're going to take a look at Doxygen later in the course probably, and you might see it. But so if you wanted to make a multi-line comment at the top of your file to include your name, the date you made it, and what the file is, maybe like a description. Something like that. That's a simple way to do it is, either 3 of those or 3 of these guys, and then you need to end the multi-line with 3 more. So that's kind of how that works. So that's comments. If you find yourself, wanting to write notes to yourself or to me or whatever in your code, go ahead and throw those in there, and they won't be interpreted as said. All right, so that's kind of that, pretty basic. I touched on it a little last week, this and or not. I touched on it a little more right now. So in our conditionals, we had say you've got, you know, x is equal to 5 and y is equal to 10 like I had before. If we want to check that both of those conditions exist, is x less than 10 and y less than 20, we can do it with that. It'll check that they both have to be true then. If we say or, then it, you know, either this is true or this is true, and then our statement will run. If we say that, then this has to be true and this has to be false. Well, this entire thing has to be true. This has to be false, if that makes sense. This has to be false in order for this to become true. So we probably won't see that much with the not, but we will see and or quite often. And actually, you know, you could write this same statement, the original one that I had. That is the same as saying right, those are the exact same things. If x is less than 10, okay. If y is less than 20, okay, then do this thing. It's checking that they're both true. This is just doing it in one step. So it eliminates some of the depth to our code, makes it easier to read, quicker. We don't have to write another if statement. It's all just done here once, checked once, makes your code run quicker. So that's the and or not. I'm not going to go into too much depth on it. Just know that there's and or not, and you should use them if you have multiple conditions that need to be met. Okay, so we're going to start looking at while loops here. And we're going to start, there's two types of loops. Well, there's actually probably a lot more. There's a do while. Okay, we're not going to look at that. That doesn't matter. There's a while. And basically the way it works is it says while some condition is true, then do this thing over and over. So what I mean by that is it works kind of, you know, it looks a lot like our if statement. Except that when our if statement happens, it says if this condition is met, then do this thing once. Right? Our code runs top to bottom. It hits this, okay, it comes in here if it's true, and it does it, and then it keeps going, you know, so on and so forth. Well, once you get to a while loop, it's going to say, is this condition true? If it is, come in here and do this thing. And when it's done doing whatever you have in here, right, even if you have, you know, 100 lines, blah, 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 line 100, let's say. So it comes in here, it says, is this thing true? Yeah, okay, we'll do this, then do this, then do this, then do this. And when it's done, rather than just saying, all right, well, what's next? No, it's not going to do that. It's going to come back up here and it's going to say, is this thing still true? If it is, do it over again. And then when you get back to the bottom, control says, all right, let's go check again. Is this still true? If it is, do it over again. Continuously. That's the loop, right? Comes in here, works its way down to the bottom. Once it gets to the bottom, it says, all right, let's go back to the top. Okay, is this condition still being met? If it is, do it over again. So in a sense, it's this really the same kind of idea here that we had with these conditionals. It's still using a conditional. It's still checking whether or not something is happening, whether it's true. The difference is what happens when it finishes. When it finishes, it checks again to see if it's still true. So that said, the way that you write a while loop, let's say we've got x and it's equal to 5. No, let's make it 0. While x is less than 5, print x. Okay, so if I were just to run this code right here, right now, x is 0, while x is less than 5, print x. What's it going to do? Well, it's going to print 0 forever, right? X is always less than 5. it's going to print 0 forever and ever and ever, right? I can show it to you. Well, that's not right. Let me save this code. Okay, so it's just running. It's printing 0 forever and ever and ever. All right, I had to keyboard exit that because it was just going to run forever. That's called an infinite loop. And an infinite loop just means there's no condition that will ever make this false, right? X never changes, so X can never become false. So if we look at the control here, right, while X is less than 5, is X less than 5? Yes, X is 0. Okay, print X. Well, when it's done printing X, like I told you, it's going to, that's the end of the loop. That's the end of our code here, this conditional code. It's going to come back up here and it's going to say, okay, well, is X less than 5? Yes, it's still less than 5. It's still 0. Okay, so print X again. Okay, when that's done, it's going to come back up here and say, is X less than 5? Yeah, it is. It's still 0. X is never changing. It's always going to be 0. So it's just going, is X less than 5? Yeah, it's 0. Print. Is it less than 5? Yeah, it's 0. Print. Is it less than 5? Yeah, it's 0. Print. Forever and ever and ever, like you saw that code run. It just printed, a million zeros. So what we have to do is we have to stop X being 0. So what does that mean? I can come in here and I can say X is 6, right? After the first time that I run this. So if I run this code now, okay, it printed 0. X became 6. So it checked again. Is X less than 5? No, it's not. It's now 6. So don't do this code anymore. So it ran one time. It showed us that it was 0. Well, that's not really very useful. What would be more useful is if we could control how X changes. What I mean by that is, what if I could say this? So my statement hasn't changed. While X is less than 5, do this thing, print X. What's changed is what X is becoming. So the first time through this loop, so I'm just going to have a little control down here, right? So the first time through, X is equal to 0. We know that. Well, it gets in here, X 0, print out X. Okay, it's going to show 0. What happens in this line? On this line, I said X is equal to itself plus 1. So 0 plus 1. Well, X is now equal to 1. So the second time through, X is equal to 1. What's it equal to on the third time through? Well, third time through, it comes and says print X. We know that X is 1 from the last step. Okay, well, X is now equal to itself plus 1. 1 plus 1, which is 2. Okay, so the fourth time through, what is X equal to? Well, you should be able to get the handle on this, that we're just adding 1 every time through here, right? X is growing by 1 every time through this loop. Okay, so the fifth time through, X is going to be equal to 4. The sixth time through, X is going to be equal to 5. Okay, and once it becomes 5, this is no longer true. It's not less than 5. So we're never going to print that. We're never going to see this line. So the sixth trip through never happens. We're going to get 0, 1, 2, 3, 4, 5. Just like that. So if I save this and run it, you should see the output of 0, 1, 2, 3, 4. So that's great. We've increased our X by 1 each time through. We no longer have the infinite loop that we had before because our X is now changing. And we're able to get some conditions set where this is no longer the case. All right, so that's a pretty common use for for loop, or for while loops rather. Another one would be something like this. Let's say X is 0, and I'm just going to make another variable and I'm going to call it test. And test is true. My while loop is going to test only. And I'm going to print out my X. I'm going to say X plus 5. And my test here is going to be if x is greater than 50, then change test to false. All right, so let's take a look at this code here real quick and just see kind of what's going to happen here. So I'm no longer testing anything on x. I'm testing this variable called test. And this is essentially saying the same thing as this. While test is equal to true, you just don't need to write it. It's a shorthand version of it. While test, right? While test equals true is basically what we're testing when we write it this way. So while test is true, go ahead and print x. Then go ahead and change the value in x, add 5 to it each time through this loop. If the value of x at some point becomes greater than 50, then test becomes false. Alright, so let's see if that is in fact the truth. See if we can run that and it doesn't error out. Cool. So it ran 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Because I was testing only greater than. So when it equaled 50, it was fine. It didn't become false until it hit 55. So this is just a different way of looking at basically the same type of thing. The difference here is that we're not testing totally sequentially. What I mean by that is previously we were just testing, x, add 1 to it, 1, 2, 3, 4, 5, right? If it gets greater than some number or less than some number or whatever the case might be, depending on how we're either adding or subtracting, then the loop should exit. Here we're testing on something else. We're testing another variable which we are controlling whether it's true or false, right? I could say, something totally different here. If x mod 2 is equal to 3 and change this to 1, then test is false. That'll never be true. Let's try a different number. 4. Okay, so what am I asking here? I'm saying while test is true, which it starts off as, print x. Add 1 to x. If x divided by 4 has a remainder of 3, then test is false. Let's try it out. 0, 1, 2. Once we hit 3, 3 divided by 4 gives you a remainder of 3. Test becomes false. So we're no longer doing something sequentially, is the point I'm trying to make here. We're no longer able to just write in the simple way, right? That's no longer the case. We could write that and it would work. But what the point I'm trying to make is that there are more advanced things coming. There are more advanced conditions that you're going to need to check. And when you need to start checking them, you're going to want to know that you can use a Boolean variable within this while and tell it kind of what to do within that, and then have ultimate control over what sets that thing to true or false. And that's kind of the main point behind a while loop. The first thing that we used, where we just had x is 0 while x less than some number, print x and make x grow by 1, is something that I'm going to show you right now is much easier done within a for loop. And that's kind of the reason behind a for loop. So transitioning here into for loops, we've seen this one. We've seen how it works. Before we move on, I want to show you a quick shorthand. So x equals x plus 1 can also be written in most languages like this, x plus plus, and it just means add 1 to myself. In Python, that's written in this manner. and it just says x, add 1 to myself. So x, if x is 0, add 1 to it, it's 1. Next time through, it's 2, 3, 4, 5, so on and so forth. So it means add this number to myself. Okay, so if it's easier for you to understand as this line, x equals x plus 1, go ahead and use that. If it's easier to understand and you get it and you just want to shorthand it, this is the shorthand for it within Python. Okay, so I'm going to leave this one as is, and we're going to hop over into these for loops. So for loops, well, while loops are used when you want to test a condition being true and then change it within the loop, right? So I'm changing it here. We saw the other example where we just had, a variable called test was true, and test at some point became false, right? So with that, we've got these other things called for loops, and I want to show you what they look like in most languages before I show you what it looks like in Python. It'll make more sense once we see what it looks like in Python if you know what's actually happening. So in most languages, this example that I've just given you is so common. You set a variable to 0, you test that it's less than, or in fact less than equal to something, then you print it, then you increase it by 1. It's so common that they made this thing called a for loop. And the way that it looks in most languages is like this. Remember I told you that x plus plus means add 1. Alright, so most languages, say you're talking C, C++, JavaScript, PHP, Ruby, I assume, looks something like this, Java, languages that have this C syntax using semicolons and things of that nature, they do this all in one line. They do this entire thing that we just saw here. If we wanted to write this print x as what is happening. They do it all in one line, and so what's really happening here is it says for x equals 0, so it means create a value x, a variable, create a variable x, store it as 0. Then next comes the test. While it's less than 5, then what do you want to do to it? Well, then add 1 to it every time through. So this is how for loops work, and like I said, this case is so common that you just want to loop over something X amount of times that they created a for loop to just do something X amount of times. The while loop can do a bit more because it can test whether something is true or false inherently, like that test variable. For loops cannot do that. They simply say, hey, how many times do you want me to do something? Okay, I'll go and do it that many times. So they do test this, but they're also always increasing it. It's not, you can't create an infinite for loop. And I mean, unless you made this number, so large that it's just basically running a long time. It can't be infinite. It's always going to have something that kind of kills it off. So this is what it looks like in most C-based languages. So as I mentioned, right, all those languages are going to have this for loop that looks like this. And the reason that this is important to know, even if we're not learning, a C-based language, is because the developers who make languages write them in C, if that makes sense. Languages are written in C. For example, Python is written in C. So you can write languages in languages. And what that means is you've kind of got, this you've got the base level, which we'll call machine code, of, zeros and ones. Then on top of machine code, you've got assembly language. And they're kind of like our algorithms. They've got put, save, open. They've got really basic commands, and then you give like memory locations on how to do things. Then above that, you've pretty much got your kind of like base languages, which is like your C's, your C++s. And then up from there, you've got kind of higher level languages, which are like interpreted languages, which we can look at, you know, PHP, Java, Python, etc. And they run down, everything runs down. The computer only ever runs at this level. It only ever runs machine code. And, you know, we can even go a higher level up, which are kind of markup languages. HTML, JavaScript, XML, etc. And so when we talk about high level versus low level languages, what we're talking about, low level means you're writing closer to how the computer talks. High level means you're writing closer to how humans talk, closer to native language, basically. So computers, remember, they only care about numbers. That's really difficult for us. You know, we want, for example, I want to be able to type google.com. I don't want to have to type 74.125.225.46 to get to their website, right? I don't want to have to do that. I could, right? Right, that's Google's website, but I don't want to visit it there. I want to visit it by having a word. So these are this is the higher level way to do that. So when we talk about languages, they have the same type of things going on. Markup languages are often written down into interpreted languages. Interpreted languages are then written down into, you know, these like base level languages, which are then written down into assembly languages, which the assembly is then written down into machine code. So that's kind of the hierarchy of language when it comes to computer science. So we're writing here, this is kind of like the middle tier level here. It's higher than the C, the C++s, that kind of thing. It's lower than, say, HTML, JavaScript, but it's nowhere near the computer itself. So back to the main point here of, you know, these C-based languages being written this way. So what happens is when you have a Python developer, the guy who made Python, Guido van Rossum, who works at Google, he made it, and he made it knowing these languages, having these things in mind when he created it. So knowing how the for loop works, he made a for loop. So in Python, so if we look in Python, a for loop, the way it's written is quite simply something like this. Okay, so I'm going to comment this whole thing out here for purposes of the fact that it's not going to do anything if we were to run it, because it's not Python, right? C or C++ or Java or something. And I'm going to have just this loop here, which is Python. Okay, and so what's happening here is we've got this function called range. So maybe we should just look at that real quick before we even run this code. So we've got this function called range. Let's see what range does. That's not what I wanted. Nor is that. So it's apparently not going to show it to me. Alright. For whatever reason, it's going to show it like that, I guess, now in Python 3. So what range does is it creates a list of numbers. That's going to look like that. Okay? When I say range and I give it 5, It's basically saying from 0 to whatever this number is, not including. So just like this. 0 to this number by 1, not including this number. So what happens when we say that, right? If I've got 0, 1, 2, 3, and 4, it's saying make x equal to 0, 1, 2, 3, and 4, and then do it. So if we just run this through here, 0, 1, 2, 3, 4. Now I can take this line out. This line's not doing anything. It's just running this for loop. For x in the range of 5, which basically is exactly what this line says right here, for x starting at 0 up until 5, increased by 1. Guido wrote it in a way that you don't even have to write that. It's just inherent within this function that's called range. So if I save this, you'll see, same thing, 0 to 4. It's exactly what this is doing. It's just written a little differently. But this is what's happening underneath. We're creating a variable called x. It's starting at 0. It's going until 5, increased by 1 each time. So I can actually write this in a different way if you wanted to see kind of a bit more information about it. So if I save that and I run it, you'll see we still get 0 to 4. So what's happening is this range function says, okay, here's the start, here's the end, here's what I want you to increase by to get there. So the shorthand for that is just to say, okay, well, if we're always increasing by 1 and we're going 0 to 5, then just give me 5. But if you wanted to start somewhere different, say you wanted to start at 5 and you wanted to go to 10, we can do that, 5, 6, 7, 8, 9. Right? It's the same up here as if I said 5, 10. No difference. It's just kind of where we start and end. The third variable that it takes is the incrementer or decrementer. So I could increase by 2, right? I could do the same thing here. Where x is x plus 2. I could go up by 2 each time, which gives me 5, 7, 9, then it's greater than 10, so it's no longer valid. I can go backward if I wanted to go from 5 to 0 by 1. I just need to say, we'll go by negative 1. 5, 4, 3, 2, 1. That'd be the same as if I said x is 5, x is greater than 0, x, in this case, it'd be minus minus. So the for loop doesn't really take a condition in the same way the while loop does. It just simply takes x, which is a variable that I just made up right here, right now, right? I could use anything for ASDF in the range of this, print ASDF. And it's going to work the same way, 5 to 1. So I just made up that variable name. X is the most common when you're using a for loop. X, Y, and Z. N is next. Those are the most common ones. And that's really all it does, right? By default, most of your for loops that you ever write are going to be for x in the range of some number, right? Maybe it's y as input from user. For x in the range of y, we could even do y plus 1. We could do this. We could start at 1 and go to y plus 1 so that it includes whatever they entered. So if I put in 5, I want to see 1 to 5. Let's see if it worked. How many numbers do you want to see? I want to see 5. It can't because it's not an integer. Let's try that. How many do you want to see? I want to see 5. 1, 2, 3, 4, 5. So what I did there is I just said, how many do you want to see? I converted it to an integer for x in the range of 1, starting at 1. Otherwise, it's always going to start at 0 by default. Start at 1 and go up to y plus 1. Why do we have to add 1? Because it doesn't by default include the number that it goes to. So those are for loops and those are while loops. I'm sure you're going to have questions. That's fine. Shoot me an email. I'll be around. Thanks.